NEET important MCQ questions from the chapter Electromagnetic Waves. First question: an AC source is connected to a capacitor C due to decrease in its operating frequency. The correct option is option D, displacement current decreases. Second question: to produce an instantaneous displacement current of 2 milliampere in the space between the parallel plates of a capacitor of capacitance 4 microfarad, the rate of change of applied variable potential difference dV by dt must be option B 500 volt per second. Third question: a 100 ohm resistance and a capacitor of 100 ohm reactance are connected in series across a 220 volt source. When the capacitor is 50% charged, the peak value of the displacement current is option C 2.2 ampere. Fourth question: in a plane electromagnetic wave traveling in free space, the electric field component oscillates sinusoidally at a frequency of 2 into 10 raised to 10 Hz and amplitude 48 volt per meter. Then the amplitude of oscillating magnetic field is option D 1.6 into 10 raised to minus 7 Tesla. Fifth question: the magnetic field of a plane electromagnetic wave is given by, then the associated electric field will be. The correct answer is option A. Sixth question: the ratio of a magnitude of a magnetic field and electric field intensity of a plane electromagnetic wave in free space of permeability nu 0 and permittivity epsilon 0. The correct answer is option C 1 by C. Seventh question: when light propagates through a material medium of relative permittivity and relative permeability, the velocity of light is given by option A is correct. Eighth question: for a plane electromagnetic wave propagating in x direction, which one of the following combination gives the correct possible directions for electric field and magnetic field respectively? The correct option is option A. Ninth question: light with an average flux of 20 watt per centimeter square falls on non-reflecting surface at normal incidence having surface area 20 centimeter square. The energy reserved by the surface during time span of 1 minute is option B 24 into 10 raised to 3 joule. 10th question: the ratio of contributions made by the electric field and magnetic field components to the intensity of electromagnetic wave is option A 1:1 is correct. 11th question: the magnetic field in an electromagnetic wave is given by, calculate the wavelength. Option A 2 into 10 raised to minus 3 meter is correct. 12th question: an electromagnetic wave is propagating in a medium with a velocity v equal to I cap b. The instantaneous oscillating electric field of this electromagnetic wave is along plus y axis. Then the direction of oscillating magnetic field of the electromagnetic wave will be along option B plus z direction. 13th question: in an electromagnetic wave in free space, the root mean square value of the electric field is ERMS equal to 6 volt per meter. The peak value of the magnetic field is option A 2 into 2.83 into 10 raised to minus 8 Tesla. 14th question: out of the following options, which one can be used to produce a propagating electromagnetic wave? Option D, an accelerating charge. 15th question: radiation of energy E falls normally on a perfectly reflecting surface. The momentum transferred to the surface is option A 2E by C. 16th question: light with an energy flux of 25 into 10 raised to 4 watt per meter square falls on a perfectly reflecting surface at normal incidence. If the surface area is 15 centimeter square, the average force exerted on the surface is option B 2.5 into 10 raised to minus 6 Newton. 17th question: the ratio of amplitude of magnetic field to the amplitude of electric field for an electromagnetic wave propagating in vacuum is equal to option B reciprocal of speed of light in vacuum. 18th question. The dimension of nu 0 x length 0 raised to 1 by 2 are option C. 19th question. The electric and the magnetic field associated with an electromagnetic wave propagating along the plus z axis can be represented as option A. 20th question. The electric field of an electromagnetic wave in free space is given by E equal to 10 cos into 10 raised to 7 t plus kx Jacob volt per meter, where t and x are in second and meter second respectively. It can be inferred that where one of the following pair of statement is correct. Option D 1 and 3, that is the wavelength lambda is 188.4 meter, and option 3 the wave amplitude is 10 volt per meter. 21st question. Which of the following statement is false for the properties of electromagnetic waves? Option D. Both electric and magnetic field vectors are parallel to each other and perpendicular to the direction of propagation of wave. 22nd question. The electric field part of an electromagnetic wave in a medium is represented by Ex equal to 0, Ey equal to 2.5 cos into 2 pi into 10 raised to 6 radian by meter into t minus pi into 10 raised to minus 2 radian by second into x. Ez equal to 0. The wave is. The correct option is B. Moving along x direction with the frequency 10 raised to 6 Hz and wavelength 200 meter.